In this section, you will understand how to find the nth term of quadratic sequences. The nth term rule of a quadratic sequence takes the form an squared plus bn plus c. Now the question I'm going to pose to you is shown here. Why is the coefficient of n squared in the nth term rule of a quadratic sequence equals to half the second difference of the terms in the sequence? That's a question I'm posing to you. So before we do the nth term, we're going to look at the background to this, and then we can use those information to find the nth term of quadratic sequences. Here we have the general quadratic sequence as shown here. An squared plus bn plus c. So what I've done is that when n equals 1, 2 and 3, what I've done is to substitute 1 in the general quadratic sequence, and I get a plus b plus c. When I substitute 2 in the general quadratic sequence, I get 4a plus 2b plus c, which is shown here. And then when I substitute 3 in the general quadratic sequence, I get 9a plus 3b plus c. When I find the first difference, I get 3a plus b. And for the next number in the sequence there, I get 5a plus b. And when I find the second difference, I get 2a. So what we have here, the second difference is twice the coefficient of a here. So we're going to use this information here to find the nth term of a quadratic sequence. So here we have a quadratic sequence. The original sequence is 11, 21, 35, 53, 75, and 101. And you're asked to find the nth term. So what we're going to do, we're going to apply the principles as outlined in the previous clip. So we're going to find the first difference and the second difference. So in this case, the first difference here is 10. And the next one would be 14. It's going up by 14. We're adding. Next one is 18, 22, and 26. What you do, if you notice, when you add 11 plus 10, you get 21. And when you add 21 plus 14, you get 35, and so on. So the second difference, we have found the first difference. So what we're going to do now is to find the second difference. So what must be added to 10 to give us 14? That's 4. And if you note, we get a constant there for the second difference. So this sequence is a quadratic sequence. So when you find the second difference, and if you get a constant, it's a quadratic sequence. Now if you note previously, we have found that the second difference is equal to 2a. So if we found the second difference as 4, it means that 2a equals 4. So we can find 2a equals 4, which implies that a equals 2. So the general quadratic sequence, if you can recall, was an squared. Let me write it out. An squared plus bn plus c. So the first part of the sequence here can be written now as, because a is 2, so we can have 2n squared. So we need to work out the next part of the sequence there now. So in order to do that, what we have to do is to fill in the multiples of n squared of the quadratic sequence. So the general quadratic sequence you have as 1, 4, 9, and so on. I'll explain that how it's done. So what we're going to do here now is to put in 2n in this box here. And what we're going to do is to work out when n equals 1, for the first number there, that would be 1 squared times 2, that's 2. When n equals 2, we're going to have 2 squared, that's 4 times 2, that's 8. When n equals 3, we're going to have 3 squared, which is 9 times 2, that's 18. When n equals 4, 4 times 4, that's 16 times 2, that's 32. When n equals 5, 5 squared, that's 25 times 2, that's 50. When n equals 6, we're going to have 6 squared, which is 36 times 2, that's 72. Okay, so that should be 72. And what we do now, we subtract this sequence from the original. So let's do that now. 2 from 11, that's 9. And that's going to give us 13, 17, 21, 25, and 29 when we subtract. So if you note, what we get here now is a linear sequence. We get a linear sequence here. So this part here, in this box here, we need to find the nth term of this linear sequence. So let's see how the sequence is progressing here. We have 9, and then we go to 13, so we're adding 4. And we're adding 4 every time. So the sequence is going up by 4. So the nth term of this sequence, then, since it's going up by 4, the linear sequence is going up by 4. The nth term is going to be 4n. But what we need to do now is to look at the original sequence. Look at the, since it's going up by 4, it's a 4 times table. So what we need to do is to think about whether this sequence here is bigger than the 4 times table. This sequence, the original sequence here, which starts with 9. Is this sequence bigger than the 4 times table? How much bigger is it? Well, you should realize that it's bigger than the 4 times table by 5. So it's going to be plus 5. So the nth term of the linear sequence then is 4n plus 5. So the nth term then of the quadratic sequence would be 2n squared plus 4n plus 5. So this should be 4n plus 5. So really, the nth term of the sequence is 2n squared plus 4n plus 5. And that's the nth term. That's how we find the nth term of the quadratic sequence. Now, what I'm going to do, I'm going to give you some practice questions, and you're going to have a go at them. If you're not sure, what you can do is to go back to the introductory stage of the clip and develop the understanding as how you find the nth term of, find the second difference, and so on. So press pause and have a go. Thank you for listening, and I hope you do understand how to find the nth term rule of quadratic sequences.